Okay, so now we're going to do permutations when we have some identical objects. All right, so example of this, let's do a couple here. So let's say if we had, how many 4-letter words can you make with the letters in the word bike? So let's just do that one first as a bit of review here. So how many different 4-letter words could I make? That's like random words, because it could be like K-I-E-B, right? Like just anything. Well, how many could be in the first spot? 4, 3, 2,
21.
and 1, right? Okay, so what'd you get there?
21.
No.
Right.
So
No.
something went right.
4.
So,
24.
okay,
I just can't read.
24. Okay, so 24 different ways for that to happen. But now what we're going to be getting into is, what if I add the word book? And that has 2 O's that are identical. So that's what we mean by identical objects, right? They're indistinguishable. They're pretty much the same object as far as we're concerned when we make letters, right? And the idea here, so here's going to be our equation for identical objects, is it's just going to be n factorial divided by a factorial times b factorial times c factorial. So what that would mean if I was going to do this question, right, is that there'd be 4 spots, right? Well, it's going to be a little tougher now to actually think about it with these blanks. But above, right, this was 4 factorial, 4 times 3 times 2 times 1. So that'd be so for book, we'll do the same thing. It's going to be 4 factorial, 4 times 3 times 2 times 1, and then divided by the repeats. So O's show up 2 times, so then we just divide by 2 factorial. It's like we're like getting rid of the repeats. The 2 factorials is like getting rid of the repeats. And the reason, I guess, when we say getting rid of it, because if I like thought about the O's as, you know, these 2 spots, right, then that would be, you can consider those as 2 factorial, right? That could be like a 2 times 1. We're getting rid of that because they're the same thing. So when we say getting rid of it, it's like I'm dividing it out. So that's what's happening on the bottom. So 4 factorial over 2 factorial, we can do this by expanding it, would be 4 times 3 times 2 times 1 over 2 times 1. So those cancel. So it's really just 4 times 3, so that's going to be 12. So there's 12 ways that you can, different indistinguishable ways to write those 4 letters. All right, let's do this one. How many different words can be formed by the word Hazlitt? Solve by expanding the factorial and canceling. So the total number is 7. So yeah, you just write down, just count all the letters, including the repeats, right? Just count them all. So that would be 7 factorial over, and then the repeats are the t's. So that would be over 2 factorial. And then you expand them out, and then just cancel what you have there. So it would just be 7 times 6 times 5 times 4 times 3. Okay, let's do this one. So it says, how many different words can be formed by red deer? Okay, so this one just has a few more, but same idea. There's 1, 2, 3, 4, 5, 6, 7 letters. So I'm going to write down 7 factorial over, and then I'm just going to start looking for my repeats. So the R's would be, so there are, oh, that's not an R. There's 2 R's, so that's going to be 2 factorial. And then, yeah, let me make that blue. 2 factorial. And then there are 2 D's, so another 2 factorial. And there are 3 E's, so 3 factorial. So you guys could put this all into your calculator and you get the right answer too, right? You guys know where that factorial button is? Just make sure if you do it that way, you would want to put this all in brackets in the bottom, so it knows to divide by all of that. Because if you just go 7 factorial divided by 2 factorial times, it would think you meant times 2 factorial times 2. It would think you meant that, right? So just make sure you put it in the bottom with brackets. So times 2 factorial times 3 factorial. Okay, and then expanding it, so we could do it this way, right? Where, here, I'm going to do it myself too. So 7 times 6 times 5 times 4 times 3 times 2 times 1 over, and then this expanded out would be 2 times 1 and then times 2 times 1 times 3 times 2 times 1. And I put those in brackets just so you can see what they belong to. The brackets didn't really matter there at all, right? But then just start kind of canceling things out where you can. So I can see, all right, let's cancel out 2 times 1 with 2 times 1. Let's cancel, well, let's look at this 4, right? Well, I can cancel that 4 with this 2 times 1, or with 2, and this 2 times 1. Like the two of those together, right? The 4 and both those 2's. And then I've just got that 3 left, so I could cancel out that 3 with that 3. And then I've kind of canceled everything on the bottom. So all I have left here is 7 times 6 times 5. Yep.
So
Yeah, so if that 3 wasn't there, then yeah, it would be 7 times 6 times 5 times 3. Yeah, you just keep that. So you just cancel out whatever you can on the top with whatever you can on the bottom, just kind of going through it. All right, now. All right, yeah, let's do this one. You guys will definitely have questions like this one. So it says, in the mountains, regions of India, China, and Nepal, and Bhutan, it is common to see prayer flags. Each flag has a prayer written on it. The color is used to symbolize the different elements: green, yellow, white, blue, and red. How many different arrangements of the same prayer flag, or the same prayer, can Dora make using 9 flags? Okay, if there are 1 green, 1 yellow, 2 white, 3 blue, and 2 red. So the idea here is that the white ones are indistinguishable. 3 blue ones are all the same, and 2 red ones are all the same. So all this would be, there's 9 flags in total, so 9 factorial. And then divided by, and then just the repeats. So the repeats would be the white flag, so 2 factorial. The blue flag, so 3 factorial. And the red flag, so another 2 factorial. And then put it all in and get the answer. So we'll move on. Okay, now this is the same idea, but it's a specific type of question. So this one says, Julie's home is 3 blocks north and 5 blocks west of her school. How many routes can Julie take from home to school if she always travels either south or east? So what that means is that, so she's here and she wants to get here. So she can go, let's say, like this path, like down and over, or she could go like this path and down. She could go this path and down. Like those are all the different, or she could go like, do like a thing like that and get there. But she can't go this way and then back and then down and then this way. So she can only travel south or east when she's going. Okay, so the way we can do this is we can think about the number of ways in total, like the number of like blocks that she would have to go to would be 1, 2, 3, 4, 5, 6, 7, 8. And no matter what way she goes, there's going to be 8 different things, like different lines there that she's going to have to go through, right? So we can start off by saying 8 factorial. And then we're going to divide by all the repeats. And you can see that all of, like, you can write these out, right? So one route could be like this one, where that would be like 4 east or 5 east in a row, and then 3 souths, or 3 east, 2 souths, and then an east again, right? Those are all different things we could do. But all of the easts are indistinguishable from each other. They're all the same thing. They're like a repeat item. And all the souths are the same, right? They're all like a repeat item. So we can just divide by the repeat. So we can divide by, well, no matter what, there's got to be 5 easts. So it's going to be 5 factorial. And no matter what, there's going to be 3 souths. So it's going to be 3 factorial. There we go. That's it. So there would be 56 ways. Okay, let's just do this one and then we're done. So now, we're even just going to do B because A is really going to be the same there. So let's do B, and it says that we want to go from A to B. Okay, so in this case, we just have 2 different situations, and there's like a node in the middle. There's like a spot in the middle where it's all going to come together, and then we're going to go up and do it again. So what we want to do is actually just handle this in 2 ways. We want to just do like this part first and then this part second, right? And again, we're only able to go like north and west this time, right? Like we can't go backwards. So this first section here would be, well, how many in total would that be? That would be something factorial. How many paths do I have in total in that one? Six, right? No matter what, I got 6. And then, well, really you're counting the sides here, right? So then that would be over,
4 and 2.
yep, 4 factorial and 2 factorial. Don't forget to make factorials too, because those will be different. Okay, so that's what that is, right? So that's the number of ways to get to this spot right here. Yep.
Why can't you just do it one big thing and treat it as if those blank areas were actually, well, like, not there, but like, why can't you do it like 4 on the side?
So this right here is the number of ways to get to that spot. Okay, so now what we're going to do is we're going to figure out the number of ways to get from this spot where we're at to B. So what would that be?
Oh, 2 and, well,
So total,
4.
yeah, so 4 factorial over
2 and
2
2.
factorial times 2 factorial. Okay, and then what do we do with number of ways? So if there's like, you know, a certain number of ways to get to do this one and a certain number of ways to do this one, the fundamental counting principle says that we should do what with those numbers? Times them. Yeah, we multiply those, right? That was like way up at the beginning. We multiply the number of ways things can happen. That gives us the total number of ways. So that's what we have down here, right? We just multiply those together and we get 90.
So then just in your calculator, can you like type each one in separately and then times the...
Yeah, you could, yeah. But a lot of these we can just do in our head too, right? Like it's
No,
not...
you can't. Or I can't.
Yeah, we could do this, like, let's write this out because it's good practice. So 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1 over 4 times 2 times, or 4 times 3 times 2 times 1 times 2 times 1, right, for the second part. So this first part was all, okay, 4 times 3 times 2 times 1. I'm canceling all of that with all of that. And then we've got 6 times 5 over 2. So 6 times 5 is 30 divided by 2. That was all just 15. Okay, for that one. And then the second one was 4 times 3 times 2 times 1 over 2 times 1. But you guys have probably already realized that times 1 has been kind of pointless up until this point. If you want to, just don't put it there. So it's really like times 2 times 2. Cancel those. So 4 times 3 is 12 divided by 2 is 6. This is really just 15 times 6. Make sense? So 90. Yeah. All right.